Now, the chemical properties always depend on functional groups and bonding, okay? So alkanes, they only have carbon to carbon single bond and carbon to hydrogen CH bonds, okay? As I keep mentioning, okay? If it was methane, it will be just CH4. If it was ethane, okay, it will be another single bond and then have H all over it. So they are not very reactive. It doesn't mean that they are not inert, okay? We are not going to use this term here. I'm just saying that alkanes are not very reactive. They can only do two types of reactions, which is combustion and substitution, which we will take a look at now. Alright, so all of the alkanes are able to burn in air or react with oxygen. If there is enough oxygen, we call it complete combustion, and the products are carbon dioxide and water. For example, ethane CH4 plus oxygen gas would give you, if it was complete combustion, you would get carbon dioxide and water. Okay, you can balance this equation on your own. And if it was in incomplete combustion, why can, when it is not a complete combustion, when there is not enough oxygen, they give you very poisonous and toxic gases, which are carbon monoxide or carbon soot. For example, even if it was methane, if you don't have sufficient oxygen, you are only going to get either carbon, or you can write carbon monoxide plus water. Okay, so in exams, if you see, oh, the product is only carbon and water, or carbon monoxide and water, why is it so? It's because there's not enough oxygen and it's therefore an incomplete combustion. So the second reaction of alkanes is that they can react with halogens in the presence of ultraviolet radiation. Notice how I say that. For example, CH4, right? CH4 would be CH4. For a reaction to take place, these bonds have to be broken. And since they are covalent bonds, they are very strong. That's why you need ultraviolet radiation, UV light, which comes from sunlight. Okay? Because why? We need energy to break these very strong covalent bonds. Okay? And in the substitution reaction, one hydrogen atom is replaced by a halogen atom. For example, let's react methane with bromine. Bromine is Br2. When a chemical reaction takes place, one hydrogen will be replaced by a halogen atom. So what I can do is I can simply copy this. Okay, put this over here. And I can add one Br here. So where will this hydrogen go? The hydrogen will go and join the remaining Br. Okay, HBr. So what is the name of this? So since this is Br, this is called bromo. And then this entire thing CH3 is still methane, right? Because why? It's still one carbon, bromo, methane. And this HBr would simply be hydrogen bromide gas. Now, notice how I write bromo. Let's imagine if this was Cl, you would get CHLORO chloro. And if it was F, you will get fluoro. That's all, okay? So these are the naming system for halogens. So let's do another one. CH3, what is it? It's C2H6, right? So this is called ethane, as we have done before. So let's try to do it, okay? Carbon to carbon. And then I have hydrogen all over it. And I have CO2, so CO, single bond, Cl. So notice that I can replace one of the hydrogen atoms. I can replace it in here, or here, or here. Wherever I replace it, it's still going to be the same because why? It is still attached to the first carbon atom. Alright, so let's try to draw it, okay? C, 1, 2, 3, 1, 2, 3. H, 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 H. Let's try to put CO here. So whether I put CO here, or whether I put CO here, or whether I put it downstairs, doesn't matter, okay? It's still going to be attached to the first carbon atom. And you're left with HCl. So your name is what? Since this is Cl, this will be CHLORO, chloro, and this will be ethane, okay? Because you have two carbon atoms. So it will be chloroethane, and HCl would be hydrogen chloride. So when you're writing an equation, a structural formula equation, you can simply think like this. Since your Cl is going into here, it can be CH, one hydrogen has to go away, CH2, and then CH3Cl plus HCl. If you write it this way, it will be CH3, CH2, Cl. Okay, however it is still true. Okay, both answers are still correct. But let's see what happens in this situation. We call it a mono substitution because only one hydrogen atom in alkanes is replaced by halogen atom. In case like this, there can be isomers. Why? Because let's see. Okay, we take this and we put it up here. This is the, let's say, first product, and this can be second product. Okay, I'm going to move this over here. Okay, so in this case, there can be two ways that this reaction can go. Okay, it can either go this way, or it can either go this way. So my Cl can actually come to the first carbon atom, or it can go to the second carbon atom. If you go to the, this is not the third one, remember this is still your first carbon atom. Okay, so my naming system could be 1, 2, 3, 1, 2, 3. So for this one, this will simply be chloropropane. Okay, because why? My longest chain is this one, and my attachment is Cl. But for this one, we need to say where the Cl is. So since it is X halo alkane, X is your position, my Cl is in the second position, so that's why it will be 2 chloro, and your longest chain is still propane. And as usual, you will have HCl here, you will have HCl here. Alright, remember, if you put your Cl, let's say here, okay, let's put your Cl over here, and you delete this one. Let's say your H is here and your Cl is here. I'm not going to count this way because why would I want a larger number? I will start counting from the left side, which is 1, 2, 3. Okay, I won't count 1, 2, 3 and call this 3 chloropropane. I will just call this chloropropane. Okay, that's all. Alright, so you can pause the video and try to do this on your own again. Alright, so write the molecular formula of the following compounds. Let's try this one. Okay, okay, in here I've written down some steps that will help you if you're not clear yet. First of all, step 1 is to locate the longest carbon chain. So it can be 1, 2, 3 like this, or it can be 1, 2, 3 like this, or it can be 1, 2, 3 like this. So let's look at here. No matter which one I choose, the longest chain is still going to be 3 carbon atoms, so I will pick it like this. 1, 2, 3. Remember, even if I pick 1, 2, and 3, it's still going to be the same. So my branch chain is CH3 and CH3. So first of all, name that longest carbon chain. So this would be, longest carbon chain is propane, right? Propane. Okay, And then number your carbon atoms. I have done it. And then I'm going to name my branch. So since this is 2 methyl groups, this will be dimethyl. And then since I have 2 of them, it will be 2, 2, okay, because it's located in the second carbon atom. So this will be 2, 2 dimethyl propane. All right. So for the second one, what is our longest carbon chain? 1, 2, 3, 4. So it's going to be bute. Do you see any single bonds or double bonds here? Okay, figure out your ending. I don't see any. So it's simply butane. For the last one, it kind of looks tricky, but it really is not. What you have to do is locate your longest carbon chain again. So it can be, so is it 1, 2, 3? Okay, let's see. Or is it 1, 2, 3, 4? Or is it 1, 2, 3? And if I remove this and count this, this is still 1, 2, 3, 4. So by right, it should be your longest carbon chain. So it cannot be only 3. Okay. So your longest carbon chain, we've identified it here, is this one. This is your longest carbon chain. And you're going to name that longest carbon chain. So it will be butane because it's all single bonds here. And your attachment is where? One attachment or one branch chain is here, another one is here. Since both are CH3, it will be dimethyl. And one is at 2, one is at 3, so it will be 2, 3 dimethyl butane. Alright, so to draw an isomer, what I'm going to do is first name what the compound given to me is. So this is going to be 1, 2, 3, 4. That's my longest carbon chain, right? So this will be 2, 3 dimethyl butane. Now, how many carbon atoms do I have? 1, 2, 3, 4. Okay, in the long chain. Okay, in the longest chain I have 4. So to draw an isomer, I can try to draw a longer chain or a shorter chain. Let's try drawing a longer chain this time. Instead of 4, I'm going to try 1, 2, 3, 4, 5. And then try to add my 1 into here. Okay, add the 6 here. So before that, let's count how many carbons do I have. Carbon 1, 2, 3, 4, 5, 6 here. Hydrogen is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. C6H14. Okay. So let's try putting it here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So if I fill in H in all the places, I have another name. But in order to make sure that this is truly your isomer and not a duplicate, name this again. My longest chain is 1, 2, 3, 4, 5. So this is pen. Since I only have single bonds, pentane, and this is methyl group, right? It's attached as branch, so this will be methyl pentane. So this is me drawing a longer chain. Now I can try to draw a shorter chain as well. Alright, so what I can do is do the second tip, which is to draw different branch chains. Now my branch is at 2 and 3. I can try to put both at 2, right? So let's see if I can do it. 1, 2, 3, 4. And my original one is that I have C and then H3 here. As you can see here, this is at 2. So I'm going to try to move this over to the second carbon atom by putting this as CH3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's still C6H14, but I have a different name now. Okay, so what is my name here? My name is 1, 2, 3, 4. My longest chain is butane, butane, And by counting it from the left side, the small left side, 1 2 3 4, 1 2 3. Okay, I'm not going to take this. Okay, I'm going to do 2. So this will be, since this is 1 methyl 2 methyl group, this will be dimethyl, and since this is at 2 2 dimethyl butane. So that's all, okay, for today's lesson. Okay, I hope that you're able to do all the isomers and know a lot about alkanes already, and I'll see you guys again in the next video. Bye bye.